Today I'm going to explain transistor collector AM modulator. This circuit consists of a class C power amplifier, a transformer and a tank circuit. An amplitude modulated wave can be obtained by passing a carrier frequency through a class C amplifier whose gain is varied by modulating signal. Such an amplifier is known as AM modulator. This circuit is called as collector modulator because the modulating signal is connected to the collector terminal of the transistor. This is a class C power amplifier wherein R1 and R2 are used to select Q point, and a modulating signal is coupled with a plus VCC DC signal through a transformer. When an AC signal is coupled with a DC signal, we get the output like this. That means the collector terminal is biased by a varying supply, not by a constant voltage. Because of this, the reverse bias across collector base junction also varies, and as the reverse bias varies, the waveform also varies with amplitude. The output is taken across a tank circuit. This is what, as I told about the variable output waveform. The amplitude of the class C power amplifier is varied. Now, this is an input signal, that is the modulating signal we apply at the collector along with the DC voltage. This is the carrier voltage which is applied to the base of the transistor. As the modulating signal varies, the collector base junction reverse bias also varies. As this amplitude increases, the collector base reverse bias also increases. As this decreases, the collector base junction reverse bias also decreases. This is because N junction is connected to positive. So as N junction positive voltage increases, the reverse bias voltage also increases. Now, class C power amplifier produces an output which flows less than 180 degree. Its efficiency is also very high. So when a variable reverse bias is applied to a collector terminal and an input of FC frequency is fed to this class C power amplifier, class C power amplifier produces a current pulses which are not complete cycle, which are only a part of one half cycle. This current pulses varies in accordance with the applied modulating signal's amplitude. Because this is not a faithful amplification, we need to connect it to a tank circuit where unfaithful or undamped oscillations, damped oscillations are converted into undamped oscillations. Unfaithful waveforms are converted into faithful waveforms. This is the simple working of a class C collector AM modulator. The waveform is also shown. As the current increases, the amplitude of this is also varies. Now, the advantages of this collector modulator. It has a very good linearity, that is, the envelope of AM wave is same as that of the modulating signal. Thus, it is also called as linear modulator. It also has high collector efficiency as class C power amplifier is used. It produces a high output power. This modulator prevents the circuit attaining over modulation, or also we can say it avoids over modulation because collector saturation will not be 100%. At the same time, Disadvantages: because it requires a high modulating power, it gives high output power. That means not only it produces a high output power was an advantage, but to have a high output power we need to give a high input power. This is a disadvantage of transistor collector modulator. Due to non-linear response of a transistor, that means collector saturation prevents 100%, the 100% modulation also cannot be achieved. This is a simple working of transistor collector modulator along with advantages and disadvantages. Thank you for watching. Please like the video if you really like the video. Subscribe and share. Thanks once again for watching.